Hello everybody, my name is Lucas, and today we're going to take a look at a little bit of a more niche topic here. We're going to take a look at the WyzeCamPan version 3. Now, the video unfortunately recorded without audio for the first part, so for the first 15 minutes we won't have that. We're going to flash this camera today with an open source firmware called Thingino. And this is an open source firmware for the Ingenic SOC chip-based devices that there are a lot of, especially some of the Chinese manufacturers use this chip quite a lot. The issue with this specific camera though is that it is on the conditionally supported hardware section here. That means that inside of the chip there is the secure boot flag set, and that means that any firmware flashed into it needs to be signed with a certain key to actually work. Now, since we want to flash this camera anyway, and we don't have the key, we need to basically change out the chip against a brand new one so that we can still reflash it. One thing I should note is that the actual software does not sit inside of the processor. It sits in a separate flash chip that we won't really touch today. So after the initial change out of the chip, we should just see this thing boot back into its normal Wyze firmware. Now let's start and take a look on how we're gonna disassemble this. I will skip the unboxing part here for you. Now to get started, what we want to do is we want to heat the front of the camera with a fan or a hairdryer, and just make sure you spend quite some time and apply equal heat onto the front, and then use any kind of peeling tool to peel it off. Again, I will make this go a little bit faster here. Now, very gently, I tried to reapply heat and peel inside with either a screwdriver or a pick to lift up the adhesive. I also had a few camera drop-ups every now and then. After finally taking off the front part, it should basically slide right off. We are left with 4 screws in the corner. Those are normal cross screws that you can take out easily. After that, I noticed that applying some pressure on the inside with a screwdriver, carefully around all of the sides, can help getting out the plastic part, which is just stuck in at this point. Now there's a rubber gasket around it that kind of holds it in place, so maybe bend away a little bit of the sides when you lift it, which will make it easier. When you manage to get it open, just be careful. There are 2 cables, one band cable that connects the front LEDs and one smaller cable on a plug that connects the microphone of the camera. Now, I'm not the only one that is disassembling this camera, so just check around on YouTube. You will find at least one other good teardown. Two more screws to be taken out to disassemble the main PCB. After you can take out the PCB, Also, make sure you have removed your SD card from the start. After you can take out the PCB, you can disconnect the stepper motor for the tilt axis on the back side. This plug needs a bit of wiggling. Additionally, there's another flat cable which connects the USB port, so that's the main power port, and also the second stepper driver. After getting the stepper driver loose, we can take out the main PCB, and that means we're also basically done. From here on, we are gonna take a look at the chip. So here you can see the main Ingenic T31X chip. You can get these chips on AliExpress or other places. They are around $4 to $5. And on the second side, we can see the little flash chip up here. That will be important in the last part of the video. Let's take a look at the chips that were delivered from AliExpress. I have ordered 2 different variants, but T31X is what you're looking for. It might be a T31X set. I have even ordered 2 different variants. They all used to work quite okay. Now the other thing that we will need is a USB cable that is very slim in the start. I am not sure if the original cable that came with the camera supports data, but we need one that supports data. I have just taken one that had a more longer plug and have cut around the plastic away so that I can actually fit it into the bottom of the camera here. And that is what we're going to use in the end, so make sure you have that ready when you get into that adventure.
Welcome to the second part. Now we need to switch out the chip on the board with a one that does not have secure boot set, so we're going to take a look into that right now. Here I have my little board, and here I have the other chip that we will replace. First we need to take note of the orientation. Let me just put this here under the microscope. Really just make sure you notice how the chip is oriented. In this case it's up like this. Let me just show this again. Chip goes up like this when the RF module is down. Alright, so let's get started by desoldering this chip. I am using a hot air station here with a perfectly sized tool for that, so I want to just quickly put that up to 6, 7 on the airflow. I don't know if you can see that, but this has like 8 settings for airflow. I'm gonna put it on like 7. And then we're gonna put it to a temperature of around 380 degrees set temperature. Maybe a little less. Usually I have my soldering irons at 360, so yeah, that's where we are. And maybe 7 on the air. With these kind of parts, it's very important that you have a lot of air going through. So, let's get started by heating that from the top. Make sure you have a plier ready.
I'm leaving this on real time so you can actually see how long this takes. So let's just wait.
And after some time you can just take off the chip like that. And here is our SOC. Completely unsoldered. Now it's time to make sure that we have the pins on the other side nicely prepped. Be careful because the board's gonna be hot. Like hot. So if we check this out, we can see that this is pretty smooth. Very importantly, we need to get rid of any bulges that might be in the center part here, because they will make resoldering very annoying. Put it on top with quite some flux. Flux pen is the most important tool for this whole surgery. You will love it. And as you can see, there's still a tiny bit of a bulge here. So we're also going to try to get rid of that with some more desolder wire and some more flux. Let's try to use some more advanced tools like this desolder station to get rid of the last pieces here. So we're now pretty clean. We can take a look at the microscope. There's still a little bit on it, but it's not too bad. Now what I'm gonna do is I'm gonna spread some flux around the outer part here. And then I'm gonna just go over it with the soldering iron. Get some fresh solder on it. Make sure you leave it without any pins connecting. And rest assured, I'm by no means an expert, nor do I make the claim to be one. I'm just switching some chips, not like I have a lot of experience with it, but yeah. Okay, let's get our T31X replacement chip out here. Alright, now we remember how we have put this on before. Like this. Basically, we're gonna add another bit of flux before we start doing that. Now I won't be able to show you what I'm doing right now because I can't see otherwise. But what we're going to do now is we're going to place the sock on it again. Actually, I'm going to put this in a little holder here because else this is a little bit annoying. Let's put our chip on top. less in the right position maybe. And start heating it. On first sight, this looks okay-ish. Also, very careful to not kill any side components that might be around here. Careful, board very hot. And it might as well be parts that are not yet fully settled. This seems pretty good though. You can see that there's almost all of the pins, or all of the pins are somehow connected. Although if you look at, for example, these two now, they're like not perfect, like these two here. But this is pretty good. Yeah, again. These ones could be better. Always don't forget to, you know, correct your sharpness on the microscope if you are changing, of course, the height. Okay, that's a pretty good start. Alright, so finally, to clean this up, we just want to make sure we have all of the contacts connected. Now, if we take a look here at the microscope camera over here, we can already see that that is pretty okay, but we could probably even do a better job. So what I will go and do now is I will take my camera out again, put some oil. Well, maybe I'll just start with some very thin solder this time. So we'll take the thinnest. So we will get ourselves something like that, just to get rid of all of the dirt that might be under. get some fresh solder. And now I'm just gonna put the solder in next to the chip. I'm gonna go over it with the soldering iron quickly. Do that once. Just be careful to not touch any components next to your chip. See how we have added a little bit of solder here? Just really make sure no contacts are shorted out on this one. But this looks quite promising. And I may even decide to just leave it how it is right now. I'm actually fairly happy. Let's take a look here. I guess it could be prettier always, but I think this will do the job. Second side, see here, I don't know about this exactly, but on the first two pins that looked like a little bit of a bridge out. That's gonna last two pins here. Yeah, that's better. I think I'm quite fine with this. Alrighty, so what we want to do now is basically we want to power it on. So we are gonna get back our housing, which we have here, and then we need to connect the mostly this wire right here. Oh, sorry, that's not even true. Mostly it's the top connector here, this one. So I think the order of how this goes in here is like that. So the wire is here because this is where the top connector went in, like so. And basically all I really want to see right now is I want to see this boot and show some LEDs, maybe do a dance. It should at least be able to do a dance on the bottom because we are still leaving the other connector disconnected. So now we need our special USB cable to test. You can use for this test, of course, the other power cable, but we just have this right here. We're gonna get some USB power supply. Gonna plug that in and see if that works. And I guess before I move on further, I wanna get a way to measure the power draw that the device takes while I am connecting it. The best way to do that would be to have some kind of USB connector. Like this one. So we have a USB connector here, oops, where you can see it, that has the two pins, the power pins out here. No, you don't need to do that, but of course if you're unsure about your soldering skills. You should probably. So, let's have this cable connected down here. And then let's check what we have set here on our bench power supply. And we have this set to 5 volts. And turn down the current limiting a bit. And let's just get it hooked up here. No, that's not the safest way of doing it. One black and one red cable. And let's push this in. Well, 0.08 amps of current draw. Let's give it a minute. See if it wakes up. Yep, and there we go. You can see that this is rotating, and so that means the camera has powered on. Does its initial dance. Of course, the axis on top we haven't seen. So that means we are up and running, and now the next part is how we can actually flash the Wyze firmware. So to do that, we'll move back to the other workspace again. Alright, it's a little bit later now. We are on part 3 of this tutorial. Now we need to flash the camera with the Thingino firmware. To do that, we are going to use a Windows laptop. You can use a Windows or a Linux, and I just found that to be the easiest. So we're gonna look over here at my Windows laptop that I have here. I am on the Thingino.com website. Now we're gonna scroll down all the way till we find the conditionally supported ones. And here we have the WyzeCamPanV3. I'm just gonna click this to download. There we go. I've just did that, as you can see. So we're just gonna delete this for now again. But you know, this is the one I have. So now we also need to go to the Thingino wiki. So if you're on this website up here, just go to the top and find the project wiki. Now after we're here, we're gonna find the cloner, Ingenic USB cloner. And this is going to be the guide that is going to be the genius guide on how we flash this product. We are going to download the cloner for Windows here. And then we are also going to check that it is in configuration level 0. So let's just bring up this cloner here. You see I have it downloaded here. This also comes with a folder that's called drivers. So if your device shows up as usually some strange letter with an A and a tilde or something like that, you probably want to go and right click on that device in your device manager. Just a quick note, how do we get to device manager in Windows quickly? You do a right click on your home menu and then click on device manager, or Gerätemanager as it's called in German. So now we're actually going to start the cloner here. And once we have that started, now we need to go to config. If you want to do a backup, just follow the guide in the wiki on how to do config backup, but we're not going to do that right now. Make sure that the platform selected is T31X, and it says T31X SFC nor writer full. We don't want to write a partition, we want to write the full firmware new. Then go to policy, make sure you make that window wide enough. And here there's a settings button and a file picker. So in here, we're gonna wait for the file picker dialog to open, which apparently takes some time. And then we're gonna check out this Thingino WyzeCamPanV3 file. Click save, confirm, and we're done with the configuration. Now we can use the cloner and we can click on start. Now at this point we have not yet put in our camera into our computer. Now let's look at the camera, but you should probably make sure that the driver is already working. So now we have our camera with the USB cable that is the cut-off version. I'm already going to be putting that in and putting the USB into the vicinity of the port, not yet in, just so I can press it in easy. Now, the next thing we need to do is, here's our processor that we just replaced. This chip is the flash chip. Maybe you can see it better here. And you can see the dot here that marks pin number 1. So the opposite side 2 pins are the ground and enable pin of the chip. Why do I know that? Well, because if we go back to the wiki page of the Ingenic, the Thingino firmware, you can scroll down here, check out how cloning works. So writing firmware, select the no writer full, select your file, click on start on the main screen, and at this stage ensure your device is not plugged in yet. This is very important actually. Now, then locate the flash memory chip of the circuit board. Check where the pin 1 is, and then on the opposite side short out these two with a screwdriver. So we're going to do exactly that, and I have already, just to make sure, you know, here we have clicked start, right? So then we're gonna go and take our screwdriver and our USB cable, make sure we are ready here to put the USB cable into the computer. Now we're gonna flash out these 2 pins, short out these 2 pins. I'm gonna put in the screwdriver, gonna hold that for a couple more seconds. And now you can already see that it has detected the camera and started flashing right away. Now this takes a couple of seconds. Now it says erasing. And once this is done, we actually should probably unplug the camera as fast as we can. You can see the USB connector being here. Otherwise it will maybe keep reconnecting and flashing, but actually not sure. That might just happen for other cameras. So we are gonna unplug it here. And now we are pretty much done. So I wanna just quickly take this camera and fold it back, because I will probably not cover the rest of the reassembly in the video. I'm just gonna reconnect the stepper motor in the back here. And I'm gonna put this little board back into its position. And as a final step, screw in those 2 screws again. If I can find a screwdriver, or I'm just gonna leave this for now, actually. So now we will just hold it in my hand for a second. And I just want to show you that if I give this power now, we will see it boot in about a second. In reality, we would already see some lights going on here, if that would be the real camera. Now you heard click, click. Now all of the movements are going to proceed. And we are basically booted. Now what we're gonna do now is we're gonna go back to our computer. Gonna just select Wi-Fi here, and we should see the Thingino network. We're gonna connect to this one. And let's see where it redirects us. Somewhere actually, Thingino.local. And now we are basically done. We can just enter our hostname here. Oh, of course, the screen sharing now died, because of course it did. Let me just check that. Basically, we're connected to the Thingino UI on Thingino.local. If you can't directly get to that, search the router IP address that you get over the HTTP, and then enter your hostname here, your wireless network, and you can connect the camera to your network. And that is basically it. All you want to do at this point now is you want to go and reassemble your front piece make sure you don't forget to put in the microphone cable here and reconnect the connector for the front LEDs. Then carefully put this back in, put the 4 screws back in. Don't forget the two tiny ones that hold the PCB inside here. Put this back in, put the glue back on, make sure you don't cover the holes for the microphone too bad, and you're basically done. So this is the full round trip of how you flash a WyzeCamPanV3 with Thingino, which needs a replacement of the SOC. If you fail at any part during the process, I have failed a bunch of times previously, and I also had the issue that when I had running the thing for a long time, it would at some point disconnect with the other one. Let's see if this one will actually perform better. All in all, it's not an easy process. I wouldn't recommend it to anybody who has never soldered any SMD components before. So if you do, please get one of the cheaper cameras like the OIFI series that are supported by Thingino, because the flashing process will be a lot easier. It will basically just be that part 3 you just seen with flashing, like shorting out the flash chip and using the Ingenic cloner. Some cameras even have an easier process. Check out the Thingino wiki. It's a really cool project. And you can see they also support devices where there is secure boot on. And it's all quite doable actually.
Small tiny note here, because I had repeatedly problems with these chips getting warm and then the camera stops to work or becomes jerky on the motors or starts to make weird noises. So what I started doing now, this one is soldered particularly ugly, but I started adding a little bit of a heatsink in here, like this. In this case, this heatsink will serve 2 purposes. First of all, it will remove the heat from the chip. Second of all, this one is sized so that it does fit in here, like so. So it also applies some physical pressure on the chip. So this is ever so slightly bigger than the screw hole here. So it does press against the chip, the chip against the PCB. Now I have one camera on a test run for the last 4 hours without any issues, and we'll see how it goes. But I think this is a good solution if your solder skills are not the best as mine are here.
All right, my name is Lucas, and this was again a very niche topic covered on the YouTube channel. I hope it's helpful to anybody, and see you in the next one, if I get to make it. Bye bye.